Hello, today we will start a completely new topic, but a very important one. Most of your Android applications require some data to be saved. So far, we have been working on very simple applications which did not have these requirements. However, now we will be developing applications which will require some data to be saved. Android provides us multiple ways to save data and retrieve it. And in this lecture, we will learn about it. So let us get started. So as you see that motivation is very simple. We need to save some data. There are three possible ways to do it. Number one, that you can save key value pairs of simple data types in a shared preference. Number two, that you can save a file in the Android file system, and today we will learn about Android file system in more detail. And number three, you can use a very simple lightweight database called SQLite. SQLite is based on SQL databases. However, this is a version which is most suited for the mobile devices. So Android provides us these three ways, and today we are going to study them to see what is good in what scenario. So let's start with the first one, saving key value sets. This can be used to save preferences. There is a typo here. This is save preferences. The preferences that we save and later on which may also share are the preferences. For example, suppose your application starts and you want to set same volume level as the user selected last time, or you want to start your application in the type of orientation that the user selected last time. So these kind of data is very useful for customizing your application and providing a personalized view of your application to the user. However, this data must be saved across different instantiation of your application. So this must be saved in such a way that it is not lost when your app is closed. The Android provides you a very simple way to save this data by preferences. It is nothing but a key value set. So internally it uses a map. From Java, you know what a map is. In this case, this map has a key of type string, and then the value could be of any other type. And then using this map, the values are stored, and then using the key, the values are retrieved. So this is the simplest possible way of storing some data in Android. Let us quickly see an example on how it is done. So let me open an example that I have created. Let us first close our existing project. Let's open another project. So this is a very simple application that I have developed only to show you the concept of shared preferences. This application has only one activity which I created using Android Studio. Now let us go through the code line by line. So the first line, I declare a static final string which is giving nothing but just a name. So I call it preferences underscore name and I give it a name. Any name is fine. After that, I declare a boolean silent which I declare to be false. We will use this boolean value to display our concept. What we want to show is that this value is preserved across different instantiation of the application. For us, this value may represent that the user, when interacting with your application, puts the phone on the silent mode. Now, let's see what we are creating in the onCreate folder. So, our onCreate is simple, except that when we start our activity, we read the shared preferences. So, for that, we use the function called getSharedPreferences. We give it a name and we give it a context, as you can see here. So the name is the name given and then the context. And from that preferences file, I do a get boolean because I want the boolean value and I set the silent variable. So this will happen whenever my application runs. However, for the very first time, this needs also to be stored. So we need to also add some data which gets run when your activity closes down. So I have added some data in the onStop where I am using the same file and the same mode, but this time I am using an editor to edit it. And using that editor, I am using something called put boolean where I am setting the value of the silent mode boolean value. So that my key is silent mode. Here I am setting a true to it, while currently it is false. And hopefully, once I have run my application once, then it is set to the true. And then it will always return me the true. And if there is some problem, then it will return me the false. So let's run this program and see its execution and try to understand it. So I run the program, choose the same emulator that I choose always, the 6P. As you see that, let me just reduce its size. That's only increasing. Let me just rotate it so that you can see it more easily. Yeah. What we are looking for are these log messages. So our program is still starting. Let us wait. Yes, so now our app is starting. And let me set the filter. As you will see, that the initial value printed is false. This value has got printed because that initially it is false. Now let us close this application. Let's make sure that the onStop is run, and then we will restart the application, and we will hope that it will read from the shared preferences file and this value will be different. So let's press the back button. Back button kills it. Hopefully it ran the onStop. Now I will go back to the same app and I will run it. And Now you can see that the value true is printed, because last time when we exited the execution, we shared it in the shared preferences. Our key was silent mode and our value was true. And when we started it, we retrieved the value of the silent mode and we printed it. So in the very first instance, it was false, but then it is true. So let's run it again. And this time again, we only have true. And now no matter how many times we stop and run it, it will be true because that's the value that we are setting. So this example, though very small, shows you the concept of shared preferences very nicely. Let's go back to the code again. We don't do much. We only use an editor and set the value by using the put method. If you see, we can have multiple put methods. As you can see here, we have put boolean, put float, put int, put long, put string, etc., etc. Similarly, we will have the corresponding get methods for the same. So this is the easiest way in which you can store some data about your app persistently across different instantiation of your app. Now let's move to the second method, which is more convenient when you want to store more data. So saving a file. Now many of you must be familiar, and we discussed that in the earlier classes, that Android is primarily based on a Linux operating system. So internally, Android is nothing but a Linux operating system, and that's why it uses a file system which is similar to the file system that you study in your operating system course. However, there are some differences because Android runs on a mobile device. One thing which is very particular about mobile devices is this concept of internal storage and external storage. You may have seen that many mobile device comes with this extra memory card slot, while the other mobile devices do not come with it. So this extra memory card slot is usually called an external storage, and while the internal disk of the mobile is normally called an internal storage. However, to take advantage of this internal storage and external storage, some devices, even when they don't provide the extra memory card slot, divides their internal storage into two parts, that is of internal storage and external storage. We will discuss that very shortly, that why do these devices do that and what is the advantage of it. However, from the Android side, the API behavior remains same whether the external storage is a true external storage or it is just designated by the device. Now, let us see some advantages or disadvantages, or let's say properties of internal storage and external storage. So on the left side, it is the internal, and on the right side, it is the external. So the internal storage, as you know, is always available. That is, you are always sure that there is some storage available. Even the basic Android devices have some storage available for you. On the other hand, the same assumption cannot be made about external storage. Number one, your phone may not have an external storage at all. That is, it may not have a slot for the memory card. Or even if it has, when you connect your phone to your PC, for example, and you mount the external storage as USB, you cannot use it. So the assumption that it is always available is not true for external storage. Please keep that in mind when you write the code. Number two, for internal storage, whatever you save in the internal storage of an app is accessible only to the app. On the contrary, whatever you store in the external storage can be read by anyone. So be aware of this when you are developing your application. The third major difference is that when a user uninstalls an app, then the system removes all your app files from the internal storage. However, when the user installs your app and your app has stored something on the external storage, only those files will be removed which have been created with using a specific API. Rest of the files will be left on the external storage. Now, we will come and discuss it in more detail later on, but take a pause and think about the benefits as well as the disadvantages of this approach. That is, some of the files will be removed while the others will not be removed. Okay, so depending on these major characteristics or properties, we can say that internal storage is best when you want to be sure that neither the user nor other apps can access your files. So only your app can access the files. At the same time, external storage is the best place for files which do not require access restrictions. For example, if you have developed an app which takes photos using the camera, now you may want your user to see these pictures and maybe also to share them with other users. So for this, the external storage is the best. By default, your app are installed on the internal storage only, but you can use an install location attribute in the manifest to make sure that your app is installed on the external storage. So particularly if your APK is very large, you may want to enable this feature, because if you consume a large part of internal storage of a user, they are not going to like it. Now, considering these advantages, can you make a guess that why some devices designate their internal storage as internal and external? What do you think could be the advantage of it? So, as you may guess, one advantage is that now the app can decide which files are used even after the app is uninstalled and which files to be removed when the app is uninstalled. So for example, if your app is about taking pictures, you may not want to remove the photos that have already been taken. And the easiest way to do it is to store them in the external storage. Now, if you want to write to an external storage, you must request a specific permission in your manifest file, which is of type write external storage. Similarly, for reading, even though currently it is not necessary, but you may be needing a permission in future for doing even the reading of the external storage. This permission is read external storage. My advice to you is that no matter what app you develop, please ask for these permissions so that your application remains future proof. This can be set very easily in your manifest file. Here I am giving you a very simple example. User permission, Android name, Android.permission.write external storage. If you do that, when user installs your application. If it is on an older device running Android 5.0 or older version, then user will be asked for the permission at the install time. If it is a newer device, then the user will be asked for the permission at the runtime. Now, let us see that how do we save a file on the internal storage. The first step that we need to do is to find out the directory that corresponds to our application. We can get this directory by making a method call named as getFilesDirectory. Similarly, there is another method call available for us which says getCacheDirectory and returns a file representing the internal directory for our app's temporary cache files. Please do not confuse this cache with the operating system cache. These two are different. The cache of an application is the temporary cache file, consists of files which the app uses frequently. Now be sure to delete each file once it is no longer needed and implement a reasonable size limit for the amount of memory you use at any given time. Because if the system begins running low on storage, it may delete your cache files without warning. So don't rely on the cache files. Here is a very simple example. One good part of Android programming is that it is very similar to Java programming, as you have already seen. So just like in Java, once you get a file object, you can write to the file in multiple ways. Similarly, in Android, once you get a file object, you can write to the file in multiple ways. For example, here I am getting a file object. Once I get the file object from the required directory and by giving file name, I can write to the file in multiple ways. So here is a very simple example where I am using output stream to write to my file. Now, that was all about internal storage. Now let's discuss the external storage a little bit. So, as told earlier that there is no guarantee that the external storage will be available. And because there is no guarantee that the external storage will be available, you must always verify that volume is available before. Now you can query the external storage by calling a simple method called getExternalStorageState. And if the returned state is equal to media mounted, then you can read or write your files. But this verification step is very important because you can never be sure that your external storage is available, especially when your app is going to be run on different types of devices. Some of them may have external storage, some of them may not. Some of them which may have an external storage may be connected to the PC with USB mounted as a scenario. So at that time it will not be available. So it is always just good to verify. Here is a very simple code which will do it for you. So is external storage writable? State get external storage state. If it is media mounted, then return true, otherwise return false. Use this method as seen earlier. This will be the status. Here we are checking for the same, and then you can write on your external storage. Now, more details about the external storage. External storage has two types of files. One are public files and the other are private files. So the public files, as shown by their name, are the files that should be freely available to other apps and to the user. So when the user uninstalls your app, these files should remain available to the user. For example, photos captured by your app or other downloadable. Then you may also want to use the external storage to store some private files. And these files should belong to your app and should be deleted when the user uninstalls your app. Now, please note a crucial difference. When the files are on internal storage, no other user can access it. but when they are on external storage, they can be accessed. So even though we are saying private files, they are not really private. They are only private in the sense that they are not useful beyond your application. So these files are technically accessible, but ideally they should not be the type of files that are of any use. And when the user uninstall your app, the system should delete all such files. So an example of such files is additional resources downloaded by your app or temporary media files. For example, when we were making math quiz, we had these small icons. Now you may want to have 10, 20 different types of icons for your app. These icons have no meaning outside your app. So you may want to use the external storage to save this, but then all of them should be deleted if the user deletes your app. Now let us look at a small code to see how to save a public file. So here I am trying to do that. I try to get a file object, new file. Please look at this variable very carefully. I am saying directory pictures. So I am trying to get the directory for the user's public pictures directory. There are different types defined in Android, and what they help is in finding what kind of file they are so that the Android can use its other apps to display it. Suppose your app uses a code something like this, then Android can use its own knowledge to find out that okay, these files looks like picture files, and therefore maybe they can be displayed in the gallery. Similar things will be available for example for dial tone or for music files, etc. So try to use these standards when you are developing your code. Querying for free space. Again, besides knowing that your external storage is available, you must also query whether it has the space or not. You can use either of the two methods. First is a get free space, and another is a get total space. And as their name indicates, first gives you the free space available, and another gives you the total space available. Often they are used together. But be aware that the free space, if it returns the size which you just exactly need for your file, it may not actually be sufficient. So if you want to store something of 10 MB and get free space returns 10 MB, your Android system may still refuse it. So a rule of the thumb is that around 90% of whatever is returned can be used by you. So if it returns 10 MB, around 9 MB you can use. Then the next is deleting a file. Again, it is very easy. You just call a method called delete or delete file and pass the file name, and then it deletes the file. Similarly, as told earlier, if the user uninstalls your app, then Android system will delete number one, all files you saved on internal storage and all files you saved on external storage using external files directory. This was all about files, which are one of the major way of creating and storing data from your application. Next, we will learn about the database called SQL.